In your previous class, we have discussed about IPv4 addressing. And before IPv4 addressing, network fundamentals and network CCNA introduction is being started, right? The first day, in the first session, CCNA introduction and Cisco tracks and Cisco levels, and Cisco CCNA exam pattern, and day-wise schedules. Just for introduction about CCNA, I have discussed. And later, network fundamentals is being started. In network fundamentals, we have been covered the very basics, which is first 4 points networking, and types of networks, and basics of to form a network. In that, board NIC, media, networking devices, and we are continuing with logical address. This is IP address, right? So IP address are two versions, IPv4 and IPv6. We have started about discussing about IPv4. IPv4 is 32-bit address divided into 4 octets. Each octet should contain 8 bits. Each octet is being separated by using dot. And we discussed clearly how to convert from binary decimal to binary also. IPv4 address we can also call as a dotted decimal notation. So decimal numbers, right? Example 192, 168, some numbers. And all 2 power 32 combinations is 4.3 billion IPs has been classified into 5 classes. Class A, Class B, Class C has been reserved for LAN and WAN. Class D for multicasting. Class E, research and development. And how we can identify which IPs belongs to which class means has a certain range of IP addresses. There is a Class A range, this Class B range, Class C, Class D, and Class E ranges. Is all the ranges based upon the priority bits? Class A priority, Class B priority. No? Class A priority bit is 0. Class B 10. Class C 110. Class D 1110. Class E 111. Is all priority bits. And we can understand the ranges also. So later on, the Class A octet format. Class A, first octet is network portion, remaining are our host portions. For Class B, network, host. For Class C, first octet, second octet, third octet, fourth octet is it. First C is the network portion, last one is host portion. So we know that Class A network bits are 8, hosts are 24. The Class B networks are 16, hosts are 16. In Class C networks are 24, hosts are 8. So 2 power 8. Right? Yeah, 2 power 8 minus priority bits, like 2 power 8 minus 1. So 2 power 7 networks are available, but 128 networks are not valid. So 126 networks are only available in Class A. But why 2 networks are being minused in Class A? Why, guys? Anyone can tell me about why minus 2?
One broadcasting, one network address.
No, I am asking about networks. 2 networks are being minused. Why?
One is for a loopback address, one is for a broadcast address.
One is broadcast ID and one is
Loopback.
No, Dinesh, I am asking about in Class A networks, number of networks. Total are 128 networks. 2 networks have been minused. Why 2 networks is minus means one for what?
Global ID.
Loopback.
global
Right.
ID and one is
Yes, Neeraj Hari. Right. One is for global ID and one
and
for
one is
loopback ID. Okay.
Loopback.
Right. So that's it. In Class A. In Class B, 2 power minus 2, 2 power 14 networks are usable. For Class C, 2 power 24 minus 3, like 2 power 21 networks are usable in number of networks. Number of networks, right? In case of number of hosts, so here we have 2 power h minus 2. Mean 2 power number of host bits minus 2. So here why minus 2?
Broadcast ID and network ID.
That's it. So in number of host place, 2 IPs have been minus for what? Network ID and broadcast. Right. So I have a few questions here. You try to identify and tell me like 201.19.20.15. What will be the network ID of this address? Network ID of this IP address.
201.19.20 is the network ID.
20.0.
Class 20.0.
201.19.20.0 is the network ID. Right, perfect. Broadcast ID? Like 201.19.255 is a broadcast ID. In between, we have 254 valid IP addresses are available. So if your office requirement is you need 100 IP address, means 100 host. Yes, you can use a class A addresses. If your is 200 IPs, yes, you can use a class A addresses. If your requirement is 300, then which class is recommended? You can go for class B, right? So class B, for each network we have 65,534 addresses are available. Okay. So up to here we have discussed, right? Now today let me continue with the same thing. A general example. This is my PC1. It is connected to PC2. PC1 and PC2. Now PC1 address I'm using 10.0.0.0. Can I assign this IP address to PC? Can I use it?
No,
No. Why?
it is a
For the
network
network.
ID.
It's a network ID, right? We can't use this because it's a network ID. Okay. 10.0.0.1 I can use?
Yes. No, default
Use it.
router ID.
Yeah, actually we can use it, but recommend it for default gateway. So we don't say like this is only gateway. You don't think so like this. Okay.
Yeah.
Recommend is 10.01. Right. So what I'm doing is for second computer 10.2.9.8 I have assigned. PC1 IP address is 10.0.0.1. PC2 IP address is 10.2.9.8. Now PC1, PC2 will they communicate?
No.
No. Okay. This is one scenario. Second case 172.18.9.2 for computer 2 172.19.9.3 will they communicate?
No.
No.
No. Okay. The third case 192.168.1.9 neighbor PC 192.168 1.8 will they communicate?
Yes.
Yes.
Okay. See, the thing is, the same scenario, if you face in the real time, in your organizations, if you face the same scenarios, then what we can understand actually, no? In your LAN, you have 10 devices, or 20 devices, or 200 devices. So to enable communication between all devices should be in the same network. Then will you communicate actually. So now let me explain clearly. So first case, second case on the same network or different network is. Example, it's a class A, right? It's also class A IP address. So for class A address, first octet is what? Network portion. Second octet, host. Third octet, fourth octet, host. Again, PC2, first octet is network, host, host, host. Okay, listen carefully. This general example I'm telling is that see, in apartments, generally in apartments, 201, 202, 203, 204. Example, I want to reach 203. What is the 203 indicates? In your apartments, buildings, what is the 203 indicate?
It's a floor. It's a apartment number. The flat number.
And the floor.
Second
Flat
floor,
number.
right? So 2 indicates is a floors, right?
Yes.
Second floor. 1, 2, 3, 4 indicates
Flat numbers.
flat number, or we can say room number. Okay. So similarly, floors is nothing but your network portion. Rooms are nothing but your host portion. So PC1 and PC2 to communicate, both PC should be in the same floor. I mean same network portion. Now let me check here. PC1 is first octet is the network portion. Is a which floor it is? 10th floor. Your PC2 first octet is a network portion, means 10th floor. Now both are in the same floors or different floors? I mean both are in the same network or different network?
Different.
Same.
net-
Same. See, first
Yeah.
octet here 10th floor is also 10th floor, right? So same network portion. So will they communicate or not? Yes, they can. But before your answer is no. So you just focus on the network portion. PC1 network portion, PC2 network portion, both are same. So host portion can be any number, 0, 0, 0.0.1, here 2.9.8, no problem. So you need to concentrate on only the network portion actually. Network portion should be same. We come to second example. Class B. Class B, network, host, host. Here, network, host, host. It's 172 18th floor. Your neighbor PC, 172 19th floor. Now both are in same network portion or different network portion? Different. Because of is a 172 18, is a 172 19. So both are different network portion means they don't communicate generally. Right? So what about next example? It's a class C. For class C, network, host. Here, network, host. It's 192, 168, 1 dot. 192, 168, 1 dot. Here, 192, 168, 1. Now both are in same network portion or different network portion?
Same.
It's the same. Yes. Will they communicate or not?
Yes, it will communicate.
Yes,
they
they
can
will.
communicate. So what you need to focus on means, if a company, if an organization is using a class A IP addresses, your all devices first octet should be maintained same. If your company, if your office is using class B addresses, for all devices, first 2 octets should be same. Maybe within your office you're using class A addresses based upon your requirement. So first 3 octets should be same. So these things we need to more focus on. Okay. Now let me take one more example here. 192.168.9.8. For neighbor computer, 192.168.10.8. Will they communicate now?
No, sir.
No. Why?
Because
Different network portion.
Different network portion, right? So what I'm doing is I'm going to change this 10 dot into 9 dot. Now will they communicate?
Yes, they
no,
will.
sir.
No. Since the same host.
No, it's same IP address.
Again, the answer is no, because of same IP address we can't use for 2 devices. IP address conflict will come, right, Hari?
Yes, sir.
So what we need to focus, we just need to focus on network portion should be same. Your host portion should be unique address. So your PC is 9.8. Here you can use 9.82. Now as they can communicate, right? So this is the logics need to keep in mind. For class A, for class B, class C, same logic actually. Okay, guys. Now next example is 225.1.2.3. For neighbor computer, 225.1.2.4. Will they communicate?
Yes, dear.
But this is reserved, sir, already.
No, why? Answer is no.
These IPs 225 to 255. These are for reserved IPs for
Exactly. See, 224 to 239, these all are class D reserved for Mars, right?
yes.
So we cannot use this address for computers. Okay? Right. Next example, 127.1.8.9. Here, 127.1.8.10. Will they communicate now?
These are for loopback.
Yes, sir.
Loopback addresses.
Yeah.
No, this one.
No. So this is reserved for loopback. So these addresses we cannot use. Let me show you the practical. A small practical I'll show you. Yeah, see here, I'm trying to assign IP address to my computer. Click on IPv4 using following IP address. See, when I'm using 127 error, what is that error? IP address is starting with 127 are not valid because they are reserved for what? Loopback address. Please specify some other valid value between 1 and 223. So up to 223 only we can use. So even if you try to use 224, again error. 224 is not a valid entry. So 1 between 1 no. Even we can't use 0 also. If we use 0 dot, so 0 is also not valid. So what are the valid IP addresses? 1, 2, 223 except 127. Right? Okay. Now coming to same example, guys. Here PC1 and PC2 both are connected. Yeah. So I have a one office. Office name is PC. This is device 1, device 2, device 3. Here I have one server. Let's consider a FTP server, and all devices are being connected to one switch with RJ45 cable. So for this office, 1, 2, 3, only 4 hosts are available. Which class IP address do you recommend? A or B or C?
Class C.
Class C example 192.168. Let me use 1.0 network. So for computers, I'm using 192.168.1.2. For second computer, 192.168.1.3, like 192.168.1.4, an FTP server like 192.168.1.45. Some number IP address I have used. All devices can communicate each other?
Yes, sir.
Yes or no?
Yes, sir.
Yes.
Yes. Why? Because of all are in the
Same.
same network address, right? Okay. Now, after some time, one new device is being added in the network. It is connected to my network, to switch. The new device IP address is 192.168. Like 2.10. Now, new device can communicate with the server,
No.
FTP server? No. Why?
It is in a different network.
Different network.
So it is in a different network. then how I can allow this main to communicate my servers and my rest of the PCs?
Using a default
Routers.
gateway or a router.
The first thing is we need to change the IP address for the new device, right?
Yes.
So what IP need to assign for the new device?
1.5.
Like 1.network. So let me use here 1.10, right?
Okay.
So this is one method by changing IP address. But my requirement is I don't want to change the address. So by using still this IP address, I want to communicate with my network mains. Now between we require device called what?
Router.
Router. So now you tell me guys, what is the action? What is the function of router? What router will do?
Two networks.
Router will connect multiple networks.
Protocol is given.
Right. Router is a hardware device which enables communication between two or more different logical networks. So this is one network which is 192.168 2.0 network, and our server network is 192.168 1.0. So both are two different logical networks, right? Like how both can communicate by using router. So similarly, this is your mobile phone. Let's say your mobile phone IP address is 192.168.1.10 something, but you can communicate with the Gmail, you can communicate with the Facebook, you can communicate with the Yahoo, you can communicate with the Twitter, YouTube, like many addresses you can communicate with a single IP address, right? So which device are required?
Routers.
Yeah, complete your end user traffic is going to via router. So now you try to understand, guys, what is the importance of router in our internet.
So if at all we use router, there's no point of using IP address in this.
IP address is mandatory. What is the identification purpose we require, right?
Okay.
Right. All right. So this logic, and now coming to the main, very, very important logic, guys. Try to understand clearly, everyone. I hope everyone is following, right?
Yeah.
Yes.
Right. So please maintain your mic in mute, and I'll start the very important questions here. So try to focus on it. This is PC1. It's PC2. Both are connected. First computer IP address is 10.0.0.10. Second computer IP address is 10.0.0.0.20. Now, second case, 172.16.1.2. Here, 172.17.1.3. 192.168 1.10. 192.168 1.11. Now tell me, guys, first IP address belongs to which class?
Class A.
Let's say A.
Class A. Now PC1 and PC2, will they communicate in the first case?
Yes.
Yes.
Yes. Okay. Now second example, which class IP address?
Class B.
Class B. Now first PC, second PC, will they communicate?
No.
No.
Can I communicate with router?
Oh, communication okay with router. Secondary. Just basic example I'm asking.
No.
Okay. Now third example, which class IP address it is?
Class C.
Same. It can communicate.
Yeah, I request to everyone, your reply should be in the text format. Try to text it, because of few people is not able to follow the class because of the noise in the back end. Okay, so please text me, all of you. It's a class C, right? Kiran is okay now? Mr. Kiran is okay, is it clear now? Right, Kiran, okay. So the third case, two IPCs can communicate? Yes, they can communicate, right? Okay. Now listen everyone, very important. First example, it's a class A and both can communicate. I agree with you. So how we can say it's a class A IP address? how we can say it's a class A IP address means based upon range. So 1 to 126, in between all IPs belongs to class A. So it's a 10. Now how we can say both can communicate? Because of class A, first octet is the network, remaining are the host. So you're going to compare here 10th floor, 10th floor. I mean 10th network, 10th network, both can communicate, right? So that we know as a users, we know that, but how your machines can understand that? Like how your computer can come to know 10 is network portion, 0 is host portion, 0 again is a host portion, 10 is a host portion. How your PC can come to know first octet 10 is the network portion, 0 host, 20 is a host. How your PC can understand that? As a user, we know that, right? So that is very, very important logic, guys. Exactly, very good, Geeta. So class A binary bits 0 and 1. 1 indicates networks, 0 indicates host, So class A, first octet is network, second octet is host. So these information we need to convey to your computer. What is the computer language? Binary. In binary language, we have to tell a computer, hello computer, first octet is a network, second octet is a host. So these information we need to say to computer in the binary. This NHH PC does not understand, right? As a user, we know that first octet is network portion. Know how we can convey to the PCs? Network indicates ones, host indicates what? Zeros. Each octet, how many bits? 8 bits. 8 bits here, 8 bits here, 8 bits, and 8 bits. So network indicates what? Ones means 1, 2, 3, 4, 5, 6, 7, 8. Host indicate zeros. 1, 2, 3, 4, 5, 6, 7, 8. Again host. 3, 4, 5, 6, 7, 8. Last octet, host, zeros. 3, 4, 5, 6, 7, 8. So this information need to convey to computer. Like how we can assign that is, so what is the all ones value? We know all ones value is what? 255 dot, all zeros is 0 dot 0 dot 0. So these we call subnet mask. So subnet mask used to differentiate network portion and host portion. Like after assigning subnet mask to your computer, so then only computer can understand, your device can understand which is a host and which is a network portion. So 255 indicates what? Network portion. 0 indicates host. Right? This is a class A example. Then what about class B example? What is the class B subnet mask? Network, host. So it's a 255.255.0.0. What about class A example? Network, host. So it's a 255.255.25.0. Is it clear? So finally, what you are getting now? Network indicates 255. Host indicate what? 0. Come to the previous examples. So I have assigned 10, 0, 0, 10. But now PC don't know. So which one is the network portion, which is the host portion, right? So when your PC can understand that after assigning subnet mask, I have assigned 255.0.0.0. So by seeing the subnet mask, now your PC can understand, oh, here we have 255 means the first octet is network portion. Now by seeing the 0, now your PC can understand, oh, I am second octet is a host portion. My third octet is a host portion. My fourth octet is a host portion. Same like your second computer. So after assigning subnet mask here, now your PC also understand by seeing 55, oh, my first octet is network portion. My second octet is host, third octet is host, fourth octet host. So PC1 is announcing I am a 10.0.0.0 network. PC1 is shouting, I am a 10.0.0 network. Oh, we are both are same network. Here, let's try to communicate. You can start doing communication. Now PCB, like example B, a class B, right? Class B 255.255.0.0. Now, what your mission can understand by seeing the 255? Oh, first octet I am in a network position. Second octet 255. Oh, second octet is also I am in network position. Right. But neighbor computer, your neighbor picks also after assigning subnet mask 255.0.0. So first octet I'm a network position. Second octet also network position. So I'm a 172.16. It's 172.17. VR belongs to both are different network position. Generally, they don't communicate. So subnet mask differentiate network position and host position. So entire communication system like IP addresses logic is depends upon the subnet mask only. All of you are getting my point? Is it clear? Right. The statement subnet mask differentiates network and host portion of the IP address. Represented with all ones in network portion and represented with all zeros in host portion. Is it clear? Right. So this is all about IPv4 address. Only a few questions. .21.9.8.2. Which class IP address? Class A. Right. Very good. What will be the network ID of this IP address? Network ID, please. 121.0.0.0. What will be the broadcast ID of this IP address? 121.255.255.255. Very good. What will be the subnet mask of this IP address? Subnet mask 255.0.0. Very good, guys. So means every IP address we have the 4 parameters. You know what is it? Network ID, broadcast ID, subnet mask. In between, how many valid IP addresses? So 4 points, guys. For any IP address, 4 parameters: network ID, broadcast ID, subnet mask, valid IP address. These are the 4 points that are very important. .186.21.8.9. Which class IP address? Class B. Network ID. .186.21.0.0. Perfect. Broadcast ID. Very good. What will be the subnet mask? .255.255.0.0. So 186 is a network portion. 21 is a host portion. Sorry, 21 is also network portion. 8 and 9 is a host portion. Right? In between all IPs are valid IP address. 168, 12.19. Which class IP address? Which class? It is a class C. Network ID. Vishnu. No. Answer Vishnu. Let's see here. The class C network what? 192, 168, 12.0, right? Broadcast ID is a 192, 168, 12.255. Subnet mask 255, 255, 25.0. In between all IPs are valid IP address. How many valid IP addresses in between? 250. Right, guys. So these are all the logics we need to keep in mind. Now I hope to everyone. So we got to know by seeing the address, we can identify the class and we can identify the network ID, we can identify broadcast ID. So we can identify is a valid IP address or not, and how many valid IPs are available, and what is the subnet mask, and what is the network portion, or what is the host portion. Is all the logics need to keep in mind when you're running, when you're working with some real-time scenarios. Okay? So that is the reason IP address we call it is a logical address. We have a lot of logics is there. 32 bits are being converted to octet. Each octet should be contain 8 bits. So binary is converted to decimal, and classes, ranges, priority bits, network portion, host portion, network ID, broadcast ID, subnet mask. These are all the logics address actually, So if you clearly understand the logics, then you can become the good network engineer. Right? So these are about IPv4 address logics. So still you have any doubts, let me know. I hope everything is clear, but still you have any doubts regarding IPv4 address, let me know.
Sir, could you please explain about priority bits?
Okay. Priority, class A, priority bit is 0. For class B, priority bit is 10. For class C, 110. For class D, 1110. For class E, 111. But what is the logic here? Why class A 0? Why class B 10? Let me take example 1, 2, 3, 4, 5, 6, 7, 8. What's the value, Karun? All zeros. What is the value? Like it is 128,
0.
64, 32, 16, 8, 4, 2, 1. It's a 0.
2, 1. Yes.
Okay. How we can write as 1?
1 is 1 0 0 0 0 0 1 last one.
Okay. How we can write as a 2?
0 0 0 0 1 0.
How can I write as 3? Is it right? How can I write as a 4? The fourth place 1, remaining zeros. Like how can I write as a 5? 4 plus
4
1.
plus 1 and 1 plus 1.
Yeah. Like if keep on writing it, how can I write as a 127?
All 0, all ones.
How can I write as a 128?
1, all zeros.
Means up to 0 to 127, the first bit is a constant 0. No changes here actually, these will be changed. So 0 to 127, the first bit is what? 0 result. From 128, if we completely up to, we can write it 191, 1 has been reserved. It's clear? So practically bit class A is a 0, class B is a 1 0. Is it clear, everyone? Or is that no? Yeah, any doubts, Pavani? Very hard doubt, let me know it. Simple thing. It's 0 to 127. 0 to 127. Here numbers is being changed. First place. Second place also number changed. Third place also changed. Fourth place, fifth place, sixth place, seventh place is changed. But what about the first one? Here no changes. Only 0, right? Means 0 has been reserved. The last combination is what? Calculate as 127, 0, 1, 1, 1, 1, 1, 1. So remaining all bits once is being changed except the first bit, right? So first bit is being 0 only. For 128, same like 120, how can write as 1, 0, 0, 0, 0, 0, 0, 0. How can write as 129? 1, 0, 0, 0, 0, 0, 0, 1. Like up to 191 you can write 10 is a common. No changes here actually. We will change 192. What is the 192 value? 11000, right? So up to 223, 110 is a common. Here will be changed. Is it clear now, everyone? Yeah, right. Good. So now I'm going to show to you how to assign IP address to your computers. Generally, we can get automatically from the DHCP, but if you want to assign manually, so statically, if you want to change your computer IP address, let me show you. Same thing. Is Windows R key and type here ncpa.tpl. Network connections will be open. Network adapters. So here, network adapters has been opened. Is Ethernet port. Here you can right click on it. Properties. You click on the properties. IPv4. Internet Protocol version 4. You click on IPv4 and go to properties. So what is showing here? Obtain an IP address automatically, right? It means automatically have one IP address. Now if I change IP address, a session will be ended actually. I lost the internet. So I'm not doing this. You also don't do that because of your internet loss will be lost. So we'll take another wireless. I'll show the same thing. Properties. Click on IPv4 to properties. So use the following IP address. Click on here. Then you can use your own IP address. Example 192.168.12.10. Subnet mask 255.255.25.0. So default gateway generally first valid IP is recommended 192.168.12.1. Like you can press OK and close. Like we can assign the IP address actually. Is it clear? Okay. Any more doubts regarding IPv4 address?
Sir, hi. Much helpful if you can give one more, understanding about the subnet mask, how we can, identify the IP addresses, like, how many IP addresses are available. If I have one IP, then from there, how many range of IP addresses are available. If we can explain one more time, it will be helpful.
It depends upon the classes actually. Take example 119.8.2.9. It's class A example. It's a class A IP address, right? So for class A, network, host, how many host bits is a 24? You can just go with 2 power 24 minus how many priority bits for class A? 11 host bits, like 2 power 24 minus 2, right? So 2 power 24 is 16,777. 216 minus 2. So 16,777, 214 hosts are available for this network. For class A. For class A, for each network is there actually. One more example, 192.168.10.19. It's a class C. So class C network host. How many bits? 8 bits. So 2 power 8 minus 2. 256 minus 2, 254 IPs are available.
Got it. So based on the class of the IP address, we can determine how many IPs are available, correct?
Exactly.
Oh.
Okay, let me start about IPv6 address now. Shall we start?
But sir, there are scenarios where we give /24 /.
Yeah, that's the slash notation. I'll come to the later about it. We have advanced IPv4 classes there, so there we'll discuss it.
Oh, okay, sure. Thanks.
Sir, how is 127 reserved network, sir? 127.
Just we need one loopback IP to test TCP IP protocol. So developer is taken from A or B or C and D, E. So just they need one IP address. They took from class A, which is 127. That's it. There is no logic actually behind that. So just they need one IP. They use from class A. That's it.
So, but the range is from 0 to 223. No?
Can I ask why this loopback address we are using it? What is the
See, I have explained a lot of times. A loopback IP address to test your TCP IP protocol stack is available in your PC or not. So simply can say self-test. In your PC, your local PC is TCP IP stack is working or not. To check that, we use loopback IP address. So ping 127.0.0.0.1 IP address. If it is given reply, then TCP IP is working fine in your computer. Simply can say self-test. No, loopback IP is not for data transmission purpose. So by using loopback, we can't assign the loopback IP of your PC, right? Before I have shown you the example also. So when you're assigning 127 for a computer, you'll get an error message. So this is only for your local PC self-test purpose only communication. All right. So let me start IPv6. IP address. Two versions. One is IP version 4, IP version 6. IPv4 is 30 bits. IPv6 is 128 bits. Well, 32 bits are being divided to octet format in decimal language, right? IPv6 is a hexadecimal format. all 32 bits are being divided into octet. One octet is equal to 8 bits. Right? Like 4 octets equal to 32 bits. IPv6 hexadecimal numbers, we call it as a quartet. Like 1 quartet is equal to 4 hexadecimal. Like complete 128-bit address is being classified, like represent with 8 quartets. In IPv4 we call octet. In IPv6 we call it as a quartet. So 1 quartet is 4 hexadecimal means 8 quartets. How many hexadecimal numbers? 8 into 4. 32 hexadecimal. In IPv4, each and every octet is being separated by using dot. First octet, dot. Second octet, dot. Third octet, dot, right? So in IPv6, first quartet, second quartet, third quartet separated by using colon. Is what colons actually. First quartet, second quartet differentiate by using colon. So finally, IPv6 should be 32 hexadecimal. You know hexadecimal is what? A combination of 0 to 9 and A to M. Let us give the statements of this. To the notes. It is represented as 32 hexadecimal numbers arranged in 8 quartets. Decimal digits separated by colon. Please. For quartet, 4 bits. 4 hexadecimals. Second quartet, third quartet, like 8 quartet. Example of address. And not sensitive for ABC. So A, B, C, D, F, we can use small a also, or capital B also, like capital C also, like D, E, F. Like they're not case sensitive. You can use upper and lower, anything. Now about IPv6, 1 hexa decimal 4 bits. 4 hexadecimal is 1 quartet. Like 8 quartets is IPv6. What is the first statement? First statement, let me explain clearly. 1 hexadecimal. So first let me write hexadecimal numbers. What are hexadecimal numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What? A, it's B, it's C, D, it's E, and it's a F. Right, these are the hexadecimal numbers, right guys? So 1 hexadecimal is what? 4 bits. 4 bits means, let me take the 4 bits. So 2 power n is a bit. So 4 bits means 2 power 0, 2 power 1, 2 power 2, 2 power 3, 4 bits. So what is the value of 2 power 0? 1, 2, 4, 8. Now you tell me guys how to write 0 in binary. How to write 0 in bits? So 8 is off, 4 is off, 2 is off, 1 is off. It's a 0. Okay. Okay, now is 1, 0, 0, 0, 1. Okay, now is it 2, 0, 0, 1, 0. Okay, now is it 3. 3 means what? 2 plus 1 is a 3. So 2 place 1, 1 place 1. Remaining zeros. That's it. 4. 4 place is 1. Remaining 0. And it is a 5. 4 plus 1 is a 5. So 4 is 1. 1 is 1. Then it is a 6. 4 plus 2 is 6. So 4 is on. 2 plays on. Okay, it is 7. 4 plus 2 plus 1. So 4 is on. 2 is on. 1 is on. 8. 8 plays on. 0, 0. 9. 8 plus 1 is 9. So 8 plays 1 plays. Remaining 0. So coming to here, how can I say A? A is a value. So how can I write as A in the binary? So A means what? 10. 8, 4, 2, 1. So 10 means what? 8 plus 2. So 8 plays and 2 plays on. 1, 0, 1, 0. How can I write as a B? B is 11. Means 8 plus 2 plus 1. 8 plus 2 plus 1. 6, 12. 8 plus 4. D 13. 1, 1, 0, 1. 14. 1, 1, 1, 0. 15. 1, 1, 1. Is it clear? So means this is the first statement, guys. What is the first statement? 1 hexadecimal is equal to what? 4 bits. If you take any 1 hexadecimal, so 0 indicates 4 zeros, 1 indicates 4 bits, 2 indicates 4 bits. Like any 1 hexadecimal indicates 4 bits. Like this, 4 hexadecimals is 1 quartet. Let me write 4 hexadecimals in a combination. Example 2018. 1, 2, 3, 4 hexadecimals. So these we call 1 quartet. Second quartet 002D. 1, 2, 3, 4 hexadecimals. This is second quartet. So first quartet, second quartet separate by using what? Colon. Right. Let me write the third quartet. 1, 2, 3, 4 zeros I'm using. Again, colon. 1, 2, 3, 4, colon. 1, 2, 3, 4, colon. Like 0, 0, 0, let's say E, colon, 0, 0, 0, colon, 0, 0, 0, 0. So this is a one example of IPv4 address. Sorry, IPv6 address. This is example. So this address we need to assign to your device. Simple, easy. So let me take one IPv4 example, 10.0.0.1. This is IPv4 example. This is IPv6 example. So which is simple, IPv6. IPv4. Okay. The same question I'll ask you after some time. So be ready for that. You know, we have some rules to represent IPv6 address. Listen carefully, everyone. So I'm going to explain the same example. This is one IPv6, right? So for easily understanding purpose, this IPv6 address we can represent. You know how can represent? We have a rule to represent IPv6 address. Akshay, can you hear me? Mr. Srinivas, Dinesh Kumar.
Yes, yes, okay.
Everyone can hear me, right?
Sir.
Right. Okay.
Yes.
So this address, how we can represent, you know, we have some rules to represent IPv6 address. Listen carefully. Rule number 1. So rule number 1 is from any quartet, quartet or field we can say is the first field, second field, third field. Like from any field, any quartet, leading zeros can be optional. Leading zeros are omission. We can omission it. Optional. So means you can write 002D also. Or leading zeros is optional. Means you can omission it. You can write 2D only. I repeat. Rule number 1 is from any field. I mean from any quartet, leading zeros are optional. Leading zeros are we can omission. This is rule number 1. Now rule number 2 is from any quartet. I mean from any field, 4 successive zeros. Successfully 4 zeros is there. In 4 successive zeros, we can substitute by 0. We can replace with what? 0. Means in the field, 4 should be successive zeros. If we come to first quartet, second quartet, 3, 4, 5, 6, 7, 8. In sixth quartet, in sixth field, 0, 0, 0, E. Is it successive zeros here? In sixth field, is it successive zeros? No, right? So which fields are successive zeros? Third field, 3, 4, 5, 7, 8, right? Exactly. So successive fields we can substitute it by 0, replace with 0. Now finally, you tell me guys how we can represent this IPv6 address now by using two rules. First one, in the first field, do you have any successive zeros? No. So in first field, do you have any leading zeros? No. So as is need to write in the first field. What is that? 201A colon. Second field. So second field we have leading zeros. Like 2 zeros you can omission it. Then straight away you can write is a 2D colon. In third field we have 4 successive zeros substituted by a single 0. 0 colon 0, again 4 successive zeros, colon, again 4 successive zeros, 0 colon. In sixth field they have 4 successive zeros there? No, we have only leading zeros is there, right? So just 3 leading zeros are optional. We can write as a E colon, again 4 successive zeros, 4 successive zeros, 0 colon 0. So this is how we can represent IPv6 address by using 2 basic rules. Leading zeros can be omission and 4 successive zeros substituted by a single 0. Is it clear? Now this address, if we assign to a computer, so your PC automatically will understand here we have a 002D is available. Your PC, by seeing the 0, your PC can automatically and here we have 1, 2, 3, 4 zeros is available. Okay, your machines can automatically understand that. Is it clear, guys? The basic tutorials. Now, rule number 3. Still, we can represent. See, what is the rule number 3 is multiple fields, multiple quarters of zeros represented with double colon. Double colon. So double colon represent multiple fields, continuous multiple fields. So here we have a continuous multiple fields of zeros, right? So here we can, this all everything is being represented with what? So 1, 2, 3, 3 zeros, 3 colons is very wrong actually, no? Don't think so. 3 zeros, 3 colons, not like that. Maybe 3 zeros or 4 zeros or 5 fields of zeros just represent what? Double colon. So double colon indicates multiple fields of zeros. Clear? Right. Now tell me guys how we can represent again this IP address 201A colon 2D colon multiple fields of zeros represent with double colon. Now E again multiple fields, you can use what? Double colon, right? Okay guys, I have a very important question here. So this address I have assigned to computer. Now what your PC can understand, oh, this is a IPv6 address. So actually IPv6 address, how many quartets should be there? 8 quartets. But how many you have assigned? 1, 2, 3 only. Then how many fields are missing? 5 fields. So where is 5 fields? Where is 5 fields exactly? Your PC maybe can understand here double colon. So here only we have a 5 fields. So because of what is double colon indicates multiple fields, 5 are missing. So your PC can understand here maybe 5, or maybe here you have it 2, here maybe 3, here maybe 3, here 2, here 4, right? Your device will confuse where exactly 5 fields. So this 6 address is invalid. Your device been confused. You have used double colon. We know that here 3, we know that here 2, but how your mission can understand that? How we can convey that? So what is the double colon indicates? Simply multiple fields. Like we have assigned 1, 2, 3, 3 is assigned, remaining 5 are missing. Maybe device understand here we have a 5 fields. What is the wrong? So we can use double colon only once in a address. Multiple fields we can represent with double colon, but condition is what? Only once. So we can't use it twice here actually because of your device will confuse. Okay. So where is recommended? 3 fields or 2 fields? So instead of replacing it 2 fields, better to replace with 3 fields. So now tell me finally how we can represent this. 201A colon 2D double colon E colon 0 colon 0, right? So this address I have assigned to computer. Now what my PC understand? 1, 2, 3, 4, 5 fields assigned by administrator. So actually should be 8. So 5 fields are already assigned. How many are missing? 3 are missing. Now your PC automatically will understand wherever you have used double colon, your PC can understand, okay, here we have 3 fields of zeros. Is it clear, guys? So double colon only once in a year. It's an example. Right. Let's see a few more examples. Before that, you can see the rules. All of you, can you read it once again? Leading 0 in any quartet can be omitted. So we know that clearly. 4 successive zeros in a quartet can be substituted by 1 0. Substituted by 1 0 means don't think so 1 0 like this. 1 0 means only single 0. Right? So here 1 0 is a so 0 0 0. I can write it as a 1 0. No, don't think so like that actually. Right. Replacing successive fields of zeros with double colon. Multiple quartet with zero can be represented as double colon, but only once in an address. Clear? Right. Now let's see examples. First example, guys. So how we can represent first one? Tell me the answers. First one. I'm asking about first one. Don't go with the soon for second and third. First, you understand slowly and tell me, text me for first question answer. Come on, guys. Again, few people are getting confused. Come on, again getting confused. Akram. Come on, Geeta. See, only leading zeros can be omitted. So we can't omission the like forward zeros, right? The only leading zeros. Yeah. Stop texting me. I'll explain it clearly once again. Example 1. 2001. Do you have leading zeros here? No leading zeros. Do you have any successive zeros? No. So can you do anything about it? No, we can't do anything. No changes. As is. 2001. Colon. In second field, 0 dB8. So we have one leading zero is 8. This we can optional. We can omit it. You can omission it. You can write as a D B 8 colon. In third field, first, second, 3, 4, 5, 6, 7, 8. In third field, leading zeros is a optional. You can omission it. You can write as a 1 colon. In fourth field, do you have 4 successive zeros in fourth field? No. Have any leading zeros in fourth field? So no. So can you do any changes in fourth field? Can't do anything, right? So 1, 0, 0 as it is into right. So clear, Geeta? Colon. So fifth and sixth successive zeros. 6 are successive zeros. So means here multiple with double colon. Again, seventh field, leading zero, omission 8, you can write as EF0, colon, in 8, no leading zeros, no successive zeros. That is BC double 0. Like you can represent it as it. Clear? Okay, second one, second example.
First one, can you please explain it again, sir? Here after, the third position, 001, it's been leading by 3 zeros. That's why we have taken 1. Fourth one,
Which field?
the third one.
Third field.
After third field, I understood that. But fourth one, why we are presenting it as 100? Because here
Leading
also,
zeros mean, you know what is the leading zeros?
yes, before.
Have any value, 4 is there. Before that, you have any numbers, you can omission it. After value as this. Only leading zeros you can omission. So in our example here, 1000, after 1 is there, is not a leading zeros. As is need to write. Okay. Yeah, Dinesh, did you try this second example? How can represent second example, Dinesh? Yeah, text me fast. Right, Geeta, perfect. Mansi, again you are doing some mistake. Please check it. You have used 4 colons, 3 colons. Very wrong one. For multiple fields, only double colon. Don't use 3 colons or 4 colons. Okay? So that is why I'm telling Siv Krishna. After 4CF, we have used 4 colons. It's very wrong. It's invalid. You don't think so? 4 fields, 4 colons, not like that. If it's a 4 fields or 5 fields, just double colon only. Okay. Right, Dinesh. Very good. So first field, no changes. As is 2002 colon. Second field also no changes. 111 colon. Third field leading 0 omission it. That is 4CF. And leading 0, 4 successive, 4 successive, 4 successive, like come. We can represent with double colon, like leading zeros, can add as a 2F. So this address assigned to the computer. Now device can understand here 1, 2, 3, 4 fields is there. So where is remaining 4 fields? Then your PC automatically understands colon. Your PC can understand here we have 4 fields of zeros. Clear? Right. Next example. Example 3. Muhammad Izzat. Moeed Ahmad.
Yes, Maya.
Yeah, you use the double colon 2 times. It's wrong again. Only once in address. And Muhammad Abdel Rahman. Again, your mistake is 4 colons. Don't use the 4 colons. Double colon. Multiple fields which represent double colon only. Right. Let me write all the examples clearly. So this is 3F double colon 5D colon 0 colon 9CE. The next example 2001 colon or double colon A C E colon B 0 C. Can I use double colon again here? If we have multiple fields, can I use again? No. Already we have used, so we can't use again. Then write is a 0 colon 69.
Sir, I have a doubt here.
Yeah.
This same bit, I wrote it as 2001 single colon 0.0 FSE, then B double colon 69. Is it okay?
Yes, you can write like this also. 2001 colon 0 colon 0 colon FACE colon BC double 0 B double 0 C double colon 69 also you can use. Both are same, both are valid.
Okay, sir. Thank
You can replace here also, or you can replace here also. Oh, but only once.
you. All right.
Right. Now, this example, next example is 20 D B double colon 6666 colon 0 colon 0 0 colon 5228. Is it right? Yes, is a right actually, no? 20 DB colon 0 colon 0 colon 666 double colon 5228. First one, second one, which is a valid? Both are valid. Exactly, guys. Both are valid. But which is recommended? Second one. So because of replacing, instead of replacing two fields, you better to replace the three fields. Right? So don't think so. First one is a not valid. It's also valid actually. Is it clear? Last, finally, 128 bits of MAC address, 128 bits of IPv6 address. How we can represent? 2001 colon 1111 double colon 1. Simple. Very simple. What is it now? IPv4, IPv6, which is simple. Both are simple if you understand the logic. Huh? So someone is connected to IPv4, someone is connected to IPv6, someone is connected to both IPv4 and IPv6. Right, right. Okay. Yes, please, Vishnu. Go ahead.
So this 2001, it's a complete 32-bit one, right? If you see this octet, 4 octets in the first one, so we have 8 quadrants. So 2001. It's two. How do we represent this in binary? 2001. How do we represent? Is it something like 00000010, and then all 8 zeros?
Like this. So means one quartet,
Got it.
16 bits.
Yeah.
Till we have 8 quartets, 16 into 8, 128 bits.
Okay.
So clear about IPv6 address logics? Any doubts? Right, very good. I appreciate everyone. If you don't have a doubts, I have a doubt. Can I ask you guys? Right. So let me ask you my doubt. What is exactly? Have a PC and one more PC. Two PCs are connected. And first device IP address is 192.168.1.2. And second computer IP address is 192.168.2.2. Will they communicate? No. Okay, I agree. Right. Now, next computer also 1.2. Will they communicate now?
No.
No. Okay, I'll agree with you. Now, second computer is a 1.3. Will they communicate now? Yes. Right. Very good. So that is not my doubt actually. So now my actual question has been there. So my question is 2001:2CF:29 for first computer. So second computer 2001:2CD:29. Now tell me guys, in IPv6 will they communicate both? No or don't know? Or what is the right answer?
Don't know.
Yeah, exactly. That is don't know, right? Because of IPv4, we know the logics. No, because of IPv4, class A, class B, class C, network portion, host portion, and we can compare with the network and host, and we know that logic, right? But in IPv6, no classes, no A, B, C, nothing, no classes actually, no. Then how we can understand this IPv6? Both are in the same network or different network, and what is the logic behind this in IPv6 is? So to understand that, so first let me write this IPv6 in a 8-quartet format. Let me write in the 8-quartet format. 201:0:0:0:0:0:0:29. So 1, 2, 3, 4, 5, 6, and 8. 8-quartet. Right, next one. 2001:2CD:0:0:0:0:0:0:29. Right? So actually IPv6 address is how many bit address? 128 bit address. So out of 128, first 64 and second 64. So first 64 bits are similar to network portion. Second 64 bits are similar to host portion. So first 64 bit indicates what? First 64 bits indicates what? Network portions actually, you know. So first 64 bit means how many quartets?
4 quadrants.
First 4 quartet, not octet. First 4 quartet, right? So first 4 quartet is a network portion. Here also first 4 quartet is a network portion. Now let me check with the both 2001 same. 2CF, 2CD. So both are the same network portion or different network portion? Different. So will they communicate now? The answer is what? The answer is no, or I don't know.
No.
Now we know. No, right? Yes. No, they don't communicate actually because of different network portion. So what I'm doing is, let me change here 2CD into 2CF. I've changed to CF. Now will they communicate? Again, answer is no. Why? Because of host portion is also conflict same 0029. The host portion should be unique. Exactly. Conflict will come. So now in host portion, where will to change? in 5th quadrant or 6th or 7th or 8th, where you can change, anywhere you can change. Like not only 8th one, Shamil, so any quadrant you can change. You can change the 5th one also, 6th one also, 7th one also, 8th field also. You can change anywhere actually, It should be unique. That's it. So let me change to CF. Now to 29, make it as a 30. Now they can come. It's 2CF double colon 30. Yeah. Is it clear now, guys? How in the IPv6, how they are in the same network or different network? Is clear, right? Okay, the next question is, in IPv4, how you can say it's a class C IP address and how your mission can come to know first 3 octets are network portion. So how your PC can come to know 192 is the network, 168 is the network, 1 is the network, 2 is a host, how your PC can understand it? Based upon what? Subnet mask. Okay. So 255.255.25.0. Here 255.255.25.0. Now your PCs can understand network portion, host portion. So in IPv6, how your PC can come to know first 64 bits are network portion. In IPv4, we call it as a subnet mask. In IPv6, we call it as a subnet prefix length. So how many bits are network portion? Yes, how many bits are network portion? Now Vishnu 32. 64 is the network portion, right? So you need to indicate /64. /64. So by signing off /64, now your PC understand, okay, first 64 bits are network portion. Like how we have assigned subnet mask in IPv4, similarly /64 indicates. Clear? Yeah. So here, let me assign IPv6 address for computer. Same method. Right click on your adapters, go to properties. Click on IPv4. Sorry, click on IPv6, right? And go to properties. Use following IPv6 address. What's the option here? IPv6 address, subnet prefix length, right? So as for example, 2001 colon 2CF double colon 29. Subnet prefix length is what? 64. For default gateway, you can use 2001 colon 2CF double colon 1, first usable address. You can okay. Close it. Like we can assign IPv6 address also. Clear? So this is all about IPv6. Yeah, if it's a /64, we can make it as a /32 also. This we can customize. Default is 64, but you can make it into /32 also. If you use /32, you can understand 32 bits on network. Like back to IPv4. Back to IPv4 examples. Example class A IP address. Class A IP address example. Ten 001 or 2 or 11. Okay. Let me write 10.1.1.1. So tell me one class C example, class C address. (192, 168, 1.1 or 1.2. Okay, very good, very good. See, I'm wondering about here, the class A range is 1 to 126. Class B range is 128 to 191. Class C range is 192 to 223. I just ask example of class A. So 1 to 126 networks is there, but everyone using example is 10.0.0.1 or 10.1 or 10.2. So it means remaining IPs are not class A. So 1.1.1 is a class A example, 2 dot is a class A example, 3 dot, 20 dot, 30 dot, 126. Others are class A examples. Even for class A also, 192 to 223 addresses are available. So 193 is example, 194, 195, 200, 201, 2. But you're using 192, 168. Why, guys? Yeah. So mostly use that. So that is not a logic actually.
10 network is a private network, 192.168 is a public network. That's most commonly used.
Opposite, quite opposite, Vishnu. 192, 168 is a private.
Yeah, right. And 10 is a public.
No, even 10 is also private. Yeah, I'll explain. Just wait a minute. Okay, actually, IPv4 addresses, where we can use this IPv4 address is in private networks and public network. What is the private network? Private network is within your LAN, within an organization, within an office is a private. Office premises is a private actually, private network. So public network is what? Internet. General example, you have a YouTube server. So who can access YouTube server? I can open YouTube. You can open. Everyone in the planet, everyone can open, right? So in my organization, in my Zoom technologies, I have a server. This is my office server. So who can access the server? Everyone can access it? No, only office employees only I can access. So it's a private network. Example of banking, like bank employees can access a bank servers, right? They can log in, they have a logins, they can access it. But access that bank servers? No. And we have a Facebook server. Like who can access Facebook server? Everyone. So internet is a public network. Means where you can use public users. Everyone can use it. Private network is what? Within a LAN, within an office. So private network have to use private IP addresses. For access internet, public network is what? Public IP addresses. So private IPs are assigned network administrator. Public IPs are assigned by internet service provider. Private IPs are free. Public IPs are You need to purchase. You need to pay for it actually, You need to register. Is it clear now where we use private IP and where we use public IP addresses? Let me give the notes of it.
Okay.
Here, public IP address used on internet, it is public network. Assigned by internet service provider. Need to purchase from internet service provider. What about private IP address? Private IP's address are used organization. Is private network, right? It should be unique within the LAN. I mean, within the organization assigned by network admin. But which IPs are private IP addresses and which one is the public IP addresses is we have certain range of IP addresses here for each class A, B, C. Let me tell you that range. So class A addresses are 126, right? Out of this, IP from 10.0.0.0 to 10.255.255.255 is complete 10 dot network range is private IP address range from class A. That's it. Remaining all IPs are public IP addresses in class A. In class B, out of 128 to 191, IP starting from 172.16.00 to 172.31.255.255, it's private IP address range. So remaining all are public IP address in class B. So finally, class C, 192.168.0.0 to 192.168.255.255 is also private IP addresses. So other than private IP addresses, remaining all IPs are public IP addresses. So these ranges you need to remember, guys. Okay. So other than this range, any IP address is public IP. So these addresses will remaining all are ISP will provide. You need to purchase for remaining IP to access internet. So let me check for my computer. My computer is using IP config 192.168.0.115. Is it private IP or public IP? It's private IP. Okay. One 171.29.8.9 is private IP or public IP? One 171.29 is public IP. 182.172.16.1 it's public or private? It's public IP. 192.169.2.1 it's also public IP now. 192.169 is public. 192.168 is only private, right? Right, Manisha. 193.168.2.1. What about this? It's also public. 172.30.2.1. It's private IP. 10.2.1.2 is also private IP. Right? 192.168.0.129 is also private IP. Clear? So finally, got all the logic of IP addresses. We have discussed about a lot of logics, guys. I think everyone have understand clearly about all the logics. So now, by seeing any one address, we can understand this is a class A, and network ID we can easy to say, broadcast ID we can tell, subnet mask we can say, and valid IP address we can say, and we can find out is a private IP or public IP, and we can say where to use this, right? So we know all the logics of IP address. Yes or no, guys?
Yes, sir.
Yeah. So that logics we need to clearly understand. So these logics are very important. Yeah, Kiran, I'll tell you the later about what is the network ID and broadcast ID. Once our main routing protocols is being started, then we'll get to know about where we use network ID and broadcast ID. In my last session, we have discussed about network ID and broadcast ID. Can you please go with our previous recorded session? They can get it. Okay. All right. I hope everyone is being clear all the topics. This is all for today. Still have any doubts? Let me know it. So thanks for today. Have a nice time. Thanks everyone. Good night. If you have any doubts, I'll be in the line. Let me.
Hello?
Yeah, please.
The IP, whatever it is, not there in between this class A, class B, class C, or that IP range, all we can consider as a public IP, correct?
Apart from the range, remaining all are public IP addresses.